Hi, everybody. Welcome to the Sprint 191 review. Let's start with the MTV part. Jeff is off today, well, this morning, so I'll talk for him about it. But mainly, he's been working on fixes on the provider inventory, making sure that everything is aligned with the UI requirements as well as the VM import operator requirements. Another thing is he also extended the validation of the CRs in the controller, making sure we have a bit more tests. Another thing is the status and progress reporting in the pipeline. So what we plan to do graphically is to have a pipeline like you would have on Jenkins, for example. So you see all the steps as a dot on the line, and the step becomes green whenever you pass it. The idea here is for a VM that has multiple disks, we would have the structure of the data would be a nested hash, each disk being represented by an entry in that hash. This way, we can either expand the pipeline view to incorporate that information, or we can put that into the expandable section of the screen for the view. So it provides us more freedom in what we want to implement graphically. There was progress on the running migrations, making sure that everything from the moment you create the CR for the migration, a migration is actually an instance of the plan. So whenever you want to run a migration, you create a plan. It's a static object. But afterwards, you create a migration to say, I want to do a migration now. And the migration will take the information from the plan and actually do the migration for you. So here it's actually reporting more precisely the status for the pipeline. So it's linked to the previous change. And one thing we had forgotten, completely missed, was the ability to select the destination namespace for the VM. By default, everything was created under the OpenShift migration project, which is probably not the best way for a user to get access to the VMs. So Jeff added the support for that, and Mike will probably talk about it. It's been added to the UI too. And Jeff has has created a demo of the end-to-end migration. I'm going to. May I take the screen to share?
Good.
So, screen. I don't know how it looks like. Maybe if I. Do you see it correctly?
Looks kind of squashed by width. Does anyone else see that?
Yeah, same on mine.
Okay. So let me try to unshare and share again. I think that the resizing the window was not a good idea.
Seems okay for me.
Better now? Oh, thank
Fabian,
you.
are you there? I think we might have lost you.
No, I'm still there.
We can hear him, Eric.
Oh, I think that maybe Eric is lost. Let me go ahead then. So the idea here is to show you, here is a view at the JSON output of the inventory. So we have a VM by its ID, and it's connected to one network, or network basically, and we have two disks in the same data store. So every time we use the ID, and the same, we have a second VM that we want to migrate. So we're just showing you the information about the VM so that you see what it looks like afterwards. So this one is in a different data store. And then we have the plan here. let me pause. So in the plan, we can see that we have the source network, the two data stores that are used by the two VMs, and they all go to the standard storage class because it's just a demo environment. And for the network, we go to the pod network, which has been named Flannel network in that case. And at the bottom, we can see the IDs of the two VMs we want to migrate. So the plan, well, from a user standpoint, once you have the UI, we don't really care about the UI, the IDs. But in the plan, it's represented as IDs to be sure that the objects are unique. Mappings again. And here we just create the plan and the migration CR. And the second part of the screen is just to show, because the length of the output is too long or would be too small either way. So here we can see that we have the VM that we want to migrate. And for each VM, we have the information about the pipeline and the phase the migration is. So slightly below, you see the controller logs that say that it's reconciling, and each time it reconciles, it updates information about the disks are actually copying at a good pace. And whenever the transfer is finished, so we can see we have both disks for the migration, and they're represented separately. So this will allow the UI to do whatever we want to do later. And now it's completed. So it's the copy is completed, and we can go to the next phase, which is converting guest. So there we are running a specific pod with Virtualization. And once that step is done, we will have the VMs correctly created on the destination. So here processing is complete. We're waiting for the VM that has 2 disks, and the process is complete too. So the plan is actually completed now, and we can and is updated for the UI, and we can verify that we have the VM created on the destination. So above you can see the things. Let me go back. Those here. There were some tests before, but the 2 VMs have been created. It's been slightly fast forwarded. You can see it took 12 minutes, but we compressed that into 3. And that's it for Chef on this sprint. Franco, do you want to talk for yourself?
Hello? Can you hear me?
Yep.
So on this sprint, I don't have a demo for this one, but on this sprint, the main focus was to migrate the old operator to bundle format. So we did that at the beginning in order to also unblock all that on 4.6, which we had a prereq for, I believe, CMB 2.5. So we did that work and the non-OLM work as well, so we could do non-OLM installations of the operator. The UI fixes and migration to official upstream image was necessary because we had we had a placeholder image, and we were pointing basically to an Nginx instance, and we fixed a bunch of smaller issues like ports and networking and some other things in there. And also I started work on the MTV operator for the community operators, but that we waited until kind of the end of the sprint because community operators did not have support for bundle format yet. So they did that last week, and I'm currently working on that one right now. I think I have a pretty good idea. So I expect MTV operator to be included for next sprint. Yeah, that's more or less what happened.
Thank you, Franco.
Sure.
Quickly, you said you don't have a demo, but just before we started the sprint, I recorded a small one. So let me run it for you.
Sure.
Here I have my OpenShift cluster. So it's not running the conveyor operator yet. So the first thing we need to do is to actually go to the command line, because we need to add a data source. Well, I could do that also through the UI, but I did simpler that way. So here we just say that we're going to use the vert operator index latest, because we are using the upstream. For the operator hub, we will have to create a real version, because they probably don't like the latest. But for that demo, that should be enough. Then we come back to OpenShift. We go to the operator hub, and it takes a bit more time than usual, so I had to refresh. Once the operator index has been deployed, we have a new provider type in the operator hub, so we can just select Konveyor operator for VMs and run the installation. Just using the default setup, so the development update channel, the OpenShift migration namespace. We don't change it, but we could, and the approval is automatic. So here we just click on install. We have the normal screen from OpenShift saying that the operator is installing, and we can see it. And there it goes. The installation is pending, installing, and after a few seconds, it's going to be succeeded. So from there, we have the operator running, but we still need to create the CR to get the controller in place. So with the CR, we can pass a few options. Potentially here, we pass just nothing. There's nothing more to add because it works, and we create. So say the control condition is running. So basically what it says is that the CR is valid and the operator is going to reconcile it. So we go into the right project, check that the pods for the controller and the other services are deployed. So the first one to be deployed is Tati Analytics. It is the shared validation service from Migration Analytics. And once it's running, it takes just a few seconds, and there we've got the controller and the UI being deployed. Once they are all ready, the operator is running and ready to create the mappings and the plans. I don't have the demo for that. The one from Jeff, I think, spoke for itself. And that's it for the installation demo. With that, I come back to the main screen and hand over to Mike.
Thanks. So this sprint, we did a lot of integration. We completed OAuth login integration with the cluster, so you can authenticate in remote mode and in prod mode with the cluster. We handled some errors for SSL and cores and wrapped up a lot of our form state management and validation, so all of the things we needed to do to submit our CRs for mappings and plans. There were some enhancements and changes to status views, the pipeline summary, et cetera, and some views in the plan wizard, and as well as the providers page. We also moved my reusable form state solution into the libui package, which will be reusable across all other Konveyor UIs, which is really a time saver for anyone who's building forms in React. It's much simpler than a lot of libraries we've used. It solves some problems for us, and I've been talking to UXD about the possibility of making that part of Patternfly itself, so that's exciting. We also restructured some of the mapping steps of the wizard, which I'll show in the demo, and added filtering and added that target namespace field that you described. And the big change is that we have cluster API calls integrated, so you can create mappings and list them, you can create plans and list them, you can add real providers and secrets, you can start migrations. So I'm going to play a demo video that I recorded, which shows a lot of these enhancements and then runs a real migration from the UI. So let me try this BlueJeans feature that I've never used before. I uploaded the video to BlueJeans, so hopefully it'll play more smoothly here. Okay, so I'm going to demonstrate the progress we've made in the MTV UI for Sprint 191. We have made a lot of progress in terms of implementing API calls to the cluster for creating CRs, for mappings and plans, wiring everything up. So I'm going to start this demo in mock mode just to demonstrate something that we've done to preserve the ability to keep our preview links in our pull requests. So you can see if I go to create a mapping while I'm in preview mode, it will fail with an error that clearly says this feature is not available in preview mode. And that'll happen on any kind of mutation that you try to perform in mock mode, whether it's creating mappings or plans or providers. We'll just speed through the plan wizard here to demonstrate that. So in the plan wizard, you can choose to save the mappings you create on the fly as mappings to use later. And I've done that here, so that's why you see the 3 errors for the 2 mappings in the plan, all saying that you can't use that in preview mode. And these preview mode errors are actually coming from our mock layer, which the query doesn't know whether it's a real error or not. Sorry. So I just paused it to unmute. Eric is saying it's not going to work on Fedora. Is not everyone seeing the video playing?
I see it on Fedora, but I'm using the web UI, not the application.
Yeah, it's working on RHEL CSV with the BlueJeans app.
All right, I can switch over to a regular screen share if you want, or I can just keep playing, whatever you guys want me to do.
Was impacted.
If everyone else is okay.
Maybe just keep playing and then link it.
Maybe just keep playing it.
All right. Sorry about that. I won't use this feature again. So this is a good way to test the actual error reporting as well. Also, if you go back while you're in the wizard, it will clear those errors, so you can try again with different data. One other thing I want to show here is that if you have data typed into these form fields and you try to leave the plan wizard without completing it, it will warn you that you have unsafe data and you have to confirm in order to leave the wizard. Before we leave mock mode here, I'll show off some of the sorting and filtering that we have here. You can sort by status, you can search by name, and by status. And if I click through to one of the plan's details, you can apply filters here as well and sort on status and name and all of that good stuff. You can see some of the mocked data here where we might have more steps like pre-hooks and post-hooks and failures and that kind of thing. We're trying to mock out all the different cases you might see for preview mode. And again, you can see if you try to start a migration, you get that same failure. Okay, so we'll switch over to remote dev mode now, which is going to log into Jeff's cluster and run some real API calls. So you can see here that I've already created one plan that is not started, and on a not started plan, you can still click through and look at the list of VMs. It's just that the rest of the table will be empty until you start the plan. So I'll go ahead and create some resources for our real migration demo. I'll start with network mappings. This has been demonstrated before. You can just name it, choose your source and target providers, and you'll be presented with the resources from those providers to map. We've also added this static option pod network, which will always be at the top of the list when you're selecting your target networks, which is just your default pod network. So I'll go ahead and create this mapping, and that will create the actual CR in the back end, and it will invalidate this query and reload this table, and you can see the actual mapping in the list. So we'll do the same thing for storage mappings. I'll create another test one here.
Same deal. You've seen this before. And here we go. That's also been created on the back end and showing up in the list here. So now we're going to go ahead and go over to the plans table again and open the plan wizard. So this part you've seen before. The only addition on this general step is the target namespace field. After you select your target provider here, you get a choice of namespace to migrate your VMs into, and I'll select OpenShift migration here. But one thing to note here is you can type whatever you want in here, and if you type a namespace that doesn't exist, it will be created when you start the migration. And next we are going to filter our available VMs by looking at the tree structure of clusters and hosts and folders in VMware and selecting the folder that Jeff's test VMs are in. And that reduces our list of VMs from 45 to 10, and I can search for the specific names of the ones we're looking for and select them. I can also expand these rows here to identify the warning conditions coming from Migration Analytics if I need to see any of that. Next, we're going to choose our network mappings, and these wizard steps have actually been redesigned. Because the VMs you've selected dictate what networks you need to map, we just pre-fill those in the builder for you, and all you have to do is select the targets. You can see I can choose to create a new one, and it will pre-fill them for me, or I can choose an existing mapping. So I'll select this mapping, and it will show me the targets from that mapping and let me change them if I need to. Moving on to storage mappings, another feature of these mapping steps is that if I select an existing mapping and it doesn't have all of the source networks or data stores that I need to map to migrate these VMs, it will fill in the missing sources for me and highlight the targets that I need to select to complete the mapping. And it won't let me proceed until I've mapped all of the required sources. And because I have modified this mapping, even though it came from an existing mapping, it gives me the opportunity to save it with a new name so I can use it again later. So moving on to the final step of the wizard, we can review everything we've selected and look at the mappings again before we save the plan. But you can actually go back to any step in the wizard at any time, change anything you need to, review your choices, rename anything, whatever you need to do before you submit it. So we'll go ahead and submit the wizard, create this new plan, and there it is. You can see the ready condition on it, ready to migrate. Before we start this migration, I'm going to pop over to the storage mappings page and show that this mapping that I actually created in the plan wizard and chose to save for later has already been saved. And just to double check, I can click through to this plan and see the list of VMs, confirm that those are the right VMs, and click Start to start our migration. And there it is. Running 0 of 2 VMs migrated. I can click through and we can see the pipeline view updating. These are both starting their disk transfers, and I'm going to go ahead and speed up time. But you can see the elapsed time ticking up. You can see the data copied increasing, and then once the disk transfer is complete, you can see them moving to the second step of image conversion. And here in a second, we will see them complete their migrations. There's one. We can click through and we see 1 of 2 migrated. And then we'll see 2 of 2 here, and we can look at all of our nice green icons. And that's it. There are a couple of visual quirks to work out and some corner cases to fix, but things are working. This represents a lot of hard work from everybody up and down the stack, so it's pretty exciting to see it all coming together.
All right, that was it for my little video. Hopefully everyone could see that, and the link is in the document for anyone who couldn't. That's all I've got. If anyone has any questions.
Looks awesome.
Amazing.
Looks like we're having a tool soon.
Yeah. I have a question. I remember in the requirements we had some possibility or requirements to choose the migration network. Is it a part of this, or it's on the later stage?
That's going to be in this this coming sprint. That's one little feature that we haven't quite gotten to yet.
Okay. Yeah, and from there, the next step for also when I think it's Franco and I are going to be working on this is to make sure that it's delivered to you in QE. And it's easy to, it works exactly as it should from the installation to the end of the migration. So something we want to test earlier in our lab and then hand over to you.
Yeah. Giving it to Q is the most important part, right?
For sure. You are our first customers.
Sure.
Thank you, Mike. Well, thank you everyone who worked on that. I know it's not just Mike. Gilles, Jan, Vince, of course, for the mockups and making sure everything looks fine. It's a lot of work, as Mike said, in a short amount of time. So really thank you for that. Let's move because we're almost at half of this review. Sam, Matthew, do you want to give us a few words about your work this sprint?
Sure. So this sprint, I started out with an investigation of refactoring VMIO's reconcile loop to use our controller task itinerary. That turned out to be impractical to complete at this point. So moved on to more migration support. There's a pull request up for the controller side, more migration stuff for CDI, and work has been started on that for VMIO as well. And then the rest of my time has been spent on a number of bug fixes.
Thank you.
For me, I got libnbd building in CDI. I got an actual pull request out for that finally, and just shepherding that through the review process, and started looking into the next step for warm migration.
Thank you, Sam and Matthew. It's a little hidden because it's at the back end, but it's also a lot of work. So congrats for that sprint. And I think that's the end for MTV. Eric, do you want to take over the screen share, or I can continue if you prefer?
Sure, I'll take over. I have a couple of things I was going to share. Can you guys hear me okay?
Yes.
Great. You see my screen okay?
Just you for now.
Not yet.
Can you see the screen?
No.
No.
That's not your day with blue jeans, Eric.
Can folks hear me? I might have dropped off the call.
I can hear you.
Near you lost your voice, or your video, I mean.
I think Eric's like near the beach right now or something.
Jealous.
Hey folks, sorry. I think I dropped off when I tried to screen share. Can you hear me okay?
Yep.
Could someone share their screen? The document. I think I might drop off the call again.
Here, I'll share mine.
Thanks, Dylan. Okay. So first up, I just wanted to quickly recap the last sprint. We had a release. So we released MTC 1.3.1. So that's our first bug fix release after our 1.3 feature release. So this was released on 10.22. We had some problems with the backend pipeline. We've been working with the folks who own that process to try and resolve some of the bugs that are there. I think we happened to hit some like corner case problems due to the way that we're using our skip ranges and stuff like that just hadn't been seen before. So they're working on fixing those. So we have kind of a direct line of communication that in case they show up again with future releases, we'll be able to talk to folks and get that resolved as soon as possible. So that was a bit of a hiccup that delayed the release a little bit. The primary bugs that we fixed in this one to call out, although there were others, was there was a regression that was in our 1.3.0 release that caused objects to not be migrated on a fourth below cluster. So that bug repairs that so that it's functional on 4.3 or below. That's important. And then the second one was we had a bug that was not really a bug because it was filed before we had implemented support for 4.6. but Json did a lot of work this sprint on learning the new operator bundle format and index image process so that we can release on 4.6 and beyond, which is only using this new format for publishing operators. Which uses a new method for metadata publication. So 4.5 uses kind of a hybrid between the old app registry and the new approach. And then before that, app registry metadata is still used in the way that it used to be used. So we've kind of proved out a lot of the pipeline for publishing operators in this new world. And also we've exercised the process that backports our new metadata to the old format and publishes to Quay. So the first item on this list, well, those are the two bugs for 1.3.1. It's available on the 1.3 channel. And then again, 1.3 was their first MTC release. I don't have a demo for the first item, and you'll see why, but Dylan, could you open that first link? Thanks. Jason's on PTO, but again, he did a lot of work this last sprint, kind of learning this new world of index images. And for those of you who had used our restricted network scripts that allowed you to build a catalog source and publish custom metadata to your cluster so that you could access pre-release CAM versions, we've added that basically all had to be reworked for index images. So that was published to a repo that I have to link to the document. So that's available for folks if they want to test in 4 or 5 or above clusters with pre-release versions of MTC. And then there's a couple, this is a document that goes through instructions for testing. This is we have kind of an upstream release process now. The motivation here being that we wanted to be able to get versions of CAM with changes out to QE in a more rapid way. So now we've got a development channel that's effectively latest. So that's going to be the head of your master branches. And then we've got a channel that we're using as like our normal releases. So you'll be able to find our normal releases there. But probably the most interesting thing that Jason did here is he's got a sprint release now. So at the end of each week during a sprint, he's got a reminder so that he can snapshot the state of things. And then he's got some Ansible scripts here that will do the whole index image build and also publish to the old format. This basically means you can get MTC at the state of MTC at the end of each week of a sprint labeled, so you can go back and get it at that time, at the snapshot of the state of our whole project at that time, and then deploy that if you choose. So that's great because stuff like we've made some large scale changes across the board that affect multiple components. And in a lot of cases, it may have just been kind of a refactoring or fix, and we don't expect any changes to be seen by the user. But this lets us actually publish and get it to QE so that QE can perform their regression testing. And that's really valuable because we've had a number of bugs that have shown up that would have been fixed by this process had they been present. So this is really great. And in addition to that, Jason's done a lot of this investigation, so we can take all these learnings that we've got and everything that he's codified up in Ansible scripts, and they can probably used across the rest of the migration projects, or really anybody might be interested in using this. So it's pretty useful. Any questions on that? Cool. Thanks for driving, Dylan.
Yeah, no worries.
Yeah, so next up, we've been working on the MTC side. One of the major features of 1.4.0 is we're working to implement the ability to do the direct migration of PVs and images, which are two of the major buckets. If you think of the things that Konveyor or that MTC migrates for you, there's 3 main buckets. You've got your Kubernetes objects, you've got your PVs, which is your state, and then you've got your images. 2 of those, the PVs and the images, have proven to be a little painful in the past with relying on Valero for the PV data and Rsync in particular, and images can be a little bit brittle. So these, instead of using an intermediary replication repository, these will push the data directly to your target from your source, which is super valuable. And also we're hoping that this is a little bit more reliable and will be so it should be faster and more reliable. though we expect to default to these options after a 1.4 release. So Dylan, do you want to show your demo?
Yep. Let me just, yep, okay, I'm not muted. So, yeah, so just a little bit of background. There was a project that came out of the customer case with Experian where we had a set of Ansible playbooks that would directly rsync data from the source cluster to the target cluster. It required a pretty decent amount of setup of configuring S-tunnel and SSH keys, as well as certs for S-tunnel to work. So what we've done is we've tried to integrate this back into CAM, basically running everything in a containerized environment, so no longer SSHing onto the source nodes and rsyncing the data over. We're actually spawning up an rsync daemon pod on the destination cluster, and then some client pods on the source to rsync the data over. So here's a demonstration of driving all of this directly from the controller using a new CRD, which tentatively named MIG-direct, but that's going to change. It's be more in line with an actual copy of PV. So what you're about to see is basically an alternative workflow. As opposed to using Rustic for file system copies, we're going to use Rsync and go directly from the source to the target. This is kind of a modified version of the controller that allows us to debug so you can actually see the data moving across. So let's go and get started. So on the top, you can see the controller itself running, and on the bottom, we have the CR definition for this new thing that we're calling MIG-direct or MIG-rsync. So you see that it takes in, similar to a MIG plan, I'm sorry, let me pause it, a source and destination MIG cluster reference, and then it asks you for a list of persistent volume claims. So we're defining a namespace in the name of a PVC that we are going to want to rsync the data directly from the source to the target. So on the bottom, we are logged into the destination cluster, and then on this new pane over here, we're logged into the source. So you can see PVC0 that we just declared on the MIG-direct CR. It's a 10 gig volume, and it is filled up with 9.7 gigs of data. So we can see this here. I'll just show you this mount point, which is where the PVC is mounted. You can see it's about 9.6. So what we're going to do now is we're going to create the new CR on the destination cluster where the controller itself is running. So this is, again, sorry, this is still the source cluster. We're watching the pods in that namespace, but we're going to come back here to the destination and create this new CR. And on the top, you're going to see the controller begin to operate on the CR. It's going to look pretty similar to how you've seen the migration controller run. So it follows a task itinerary, which may change as we move forward, but for now you can see it's preparing. It's going to first make sure that on the destination the namespaces exist and these PVC definitions exist. So same volume size, and if there's any specific node requirements, created now as well. So you can see we just had this new namespace, PVC migrate bmark1, just created 3 seconds ago. You can see on the top, it is going through the process of creating the destination PVCs. You can see none exist right now. We just created one. This new controller will allow you to map storage classes, similar to how PVC migrate allows you to do that. For now, we're using the default, which is GP2 in this case. So this PVC is going to sit in a pending state until actual PVCs get created. But if you look in the bottom and the top here, so what we're doing is creating on the destination cluster an rsync daemon pod. And the rsync daemon pod essentially is going to allow any clients on the source to directly copy the data over. So we stand up one rsync daemon pod that mounts every persistent volume in a given namespace. So if I'm migrating 5 namespaces, you'll have 5 rsync daemons, one in each namespace, and each daemon will mount every PVC that exists in that namespace. So since we're only doing one for this demo.
Hey, Dylan, can you talk about how you're routing to it? Like how are you dealing with it from a network point of view?
Yep, so you can see right here, we've just created an rsync route, and then what we're going to be doing is setting up a transient username and password for rsync, and then we're going to be setting up S-tunnel. And S-tunnel is going to run with a custom set of SSH keys and certs that we are standing up entirely on our own, transiently per migration from the controller. So in the past, what we've required is the customer themselves to run a set of Ansible playbooks that would generate these certs, dump them on the source nodes, and then generate them inside of the rsync daemon pod on the destination. We're kind of doing this transiently per migration ourselves, all from the controller. So the customer needs to know nothing about configuring the networking as long as the source and destination have network access, meaning they can talk to each other. We go ahead and do the heavy lifting of creating the rsync route with stunnel, then setting up the certs and SSH keys to make this whole thing function. We'll see that a little bit more in a second. But you can see in the top right, we've created the rsync route. We're creating a set of configuration, so config maps for rsync, which is setting up a transient username and password, which the user can configure if they want. Then we set up this stunnel config, which again points to a set of custom certs that we're generating on the fly. And the next thing you're going to see is on the destination cluster, you're going to see a pod stood up with two containers, an rsync daemon container and an stunnel container. So the network communication between the two clusters is actually all going through stunnel, right? You have a diagram I can show you after this if anyone has questions about this.
And you would have like one tunnel and one route per namespace, correct? Just want to make sure I understand. Okay, sorry. It's a lot of information very quickly, so that's good. Okay,
yeah, no, I totally understand. And we can kind of go into more specifics after this. I have a diagram that kind of shows a little bit better, but you can see, right, this is the destination cluster. Per namespace, you'll get one of these things called a MIG direct rsync transfer, and it's got two containers. One is the rsync daemon, and one is stunnel. You can see that it's mounted to PVC, so this has now been bound to that transfer pod, so that when we actually perform the rsync to the daemon, it's going to write directly to this persistent volume claim, and it's backing PV. All right, so let me just pause here. So that was all in the destination cluster. On the source cluster, we have another whole other side to set up for in terms of stunnel and rsync, right? So we have to set up an stunnel client, meaning the other end of the pipe here. So we're going to stand up one pod itself per namespace that handles the stunnel transfer, meaning that it has to set up all the certs that we created on the destination side, and the set of SSH keys on the source side as well. So you're going to see this stunnel transfer pod. This is essentially the pipe from the source cluster to the destination cluster. And then the next thing is that we need to go ahead and set up what is called, I'm calling in this case, the rsync client pods, right? So on the destination, you've got the rsync daemon. On the source side, you have an rsync client. And the rsync client is what's actually going to be taking the persistent volume on the source side and copying the data through stunnel to the rsync daemon. So you can see the controller is waiting for the rsync client pods to come up into a running state. You can see it's in a running state. This is not a deployment. It's just a one-time running pod. So it's going to run the rsync to completion, then move into a completed state and stop. Right now, it's not showing the progress reporting because we still have to work out how rsync is actually writing to the logs. But what you can see it's doing here is taking this file, which is sample data. That's the 9.6 gig file that we're trying to copy to the destination. And it is directly performing the rsync through stunnel to the daemon on the destination side. So this is, again, 9.6 gigs. The total video here is not sped up. It takes about 3 minutes to set up all the configuration for everything to run on both sides. And then about 4 minutes, just under 4 minutes to copy 10 gigs. We've run some benchmarks where I had 10 gig volumes. So that's 100 gigs total, and that took about 14 minutes. So vast speed improvement compared to Rustic because you have to copy the data twice. And since we're spawning one client pod per persistent volume claim, we have the benefit of running all this up in parallel. Then your bottleneck is really network transfer at that point. It's not actually waiting for the controller to spawn all this stuff like you have with Rustic. So we're seeing a pretty good performance boost doing this. So I'm just going to speed ahead a little bit here Obviously, it's going to take a little bit to copy all this data, but you can see the client pod has only been running for about 2 minutes. It's about to run into a completed state, so it took about 2 minutes total to run this 10 gig transfer. The controller's moved into a completed state. I've had the controller in debug mode, so it's not deleting anything, but it would go now and go and ahead and clean up all of these resources to take them off the clusters. But let's go ahead and look into the Rsync daemon pod, where it's mounted this PVC, and confirm that we actually have all the data copied over. Forgot I couldn't clear there. So let's look inside of this mount folder where we've mounted all the volumes. You can see it's namespaced. So this Rsync daemon could potentially have 10 directories in here if we have 10 persistent volume claims per namespace. And you can see the sample data file, 9.6 gigs, was all copied over in just under four minutes.
This looks awesome, Dylan. If you could send me like a little diagram that shows like the connectivity side of this, I would like I think the key question here is like, what percentage of customer will be able to support that? Like, I'm hoping it's like 99%, but that would be interesting to create a slide, and every time we talk to a customer, like explain that design that it's coming, and see what kind of objections it would throw at us. Like, hopefully not many, but it looks great. But I'm just wondering, is there something we're not thinking about with some kind of customers? Definitely not going to work for everybody, right? Some people are going to be disconnected, but hopefully a large majority of them will be okay with that.
Yeah. The goal here is, we're not anticipating that you have to go and open up ports in the firewall and stuff, because it's all operating via an OpenShift route, which was the same goal we had with PVC Migrate. So the hope here is that as long as the customers have network access or connectivity between the two clusters, this should work for them.
They need wildcard DNS to be enabled, right? Because you're using wildcard. I'm wondering, like, what percentage of customers don't have that as well? Like, there's all kind of little things like that, like firewalls, and like if they have load balancers in front, like how would that be affected by that? Like, it would be interesting to run it by a bunch of people and have a better understanding, like what percentage of customers will have issues with it. But it looks great. I think that would work for the vast majority of customers, but that's something to validate, I think, in the next couple of weeks until we release it.
Yeah, absolutely. That's the hope. So yeah, next
if you have a little short diagram that explained that would be great. That would help me create a slide so we can talk more about it.
Sure thing. I will send you the design docs we have on this.
Thank you.
And then just real quick call out. So the next step here is obviously we want to integrate this back into the MIG migration workflow. So behind the scenes, when you select copy for a PV, if you have this new workflow configured, right, or enabled, then we want to use this as opposed to Rsync, because it's better in terms of catching errors, and it's a vast performance boost. So any other questions before we turn over to Scott to show the direct image migration? Cool. Scott, do you want to take over the sharing, or do you want me to share it?
I can do it. So just one quick point about, you may have mentioned this already, I'm not sure, but the Valero approach we're still using for snapshot copy. So when you choose to copy in the UI, we have a choice of file system or snapshot. If you're using snapshots, we're still going to use Valero, because that's handled by the clouds, the providers, snapshotting and restoring. So this just replaces the Rsync copy. So anyway, on the image side, kind of similar concerns. We've had customers that have had problems with the images. It's slow. One thing we don't deal with on the image copy side is we're not replacing, something like Rsync, which we're having reliability issues with. The actual physical copy using the containers image library, which is the same thing at an API level that Scopio uses, we're still using that. What we're changing is the fact that we're not making two copies. We're not copying from the source cluster to a storage location in S3, and then from on the destination side, from there to the destination, we're just going to do a direct copy from the registry on the source cluster to the registry in the destination cluster. And we're also not, several layers down in Valero in terms of debugging and understanding what happened when there are errors that pop up. So those are the main things we gain there. And the other thing that's different versus the PV copy is that we will require one additional bit of user input and that is normally the internal registry is only available within the cluster. Since the controller is going to have to copy from or to it, depending on whether it's source or destination, any remote cluster, which is any cluster that's not the same cluster that you're running your the migration controller in, is going to have to expose a route. And the default case, we're going to deal with load balancers or any of that. It just means creating a pass-through route in your cluster and providing in the UI for the cluster when you add a new cluster what that external URL is. So share my screen here, and where I am with this process is pretty similar to where Dylan was. I have a separate controller. Here, let me just. And this is fully functional there. The next sprint, we're going to be adding that into the workflow with the migrations. Okay. And is the sharing working here?
Yep.
Okay. Yeah. Okay. So what we have here is this. So this is the what the CR looks like that I'm going to create. Again, it's similar to the MIG-direct source and destination cluster averages. The main difference here is that with the PVC copy, we're having to specify individual PVCs because some of them we're not including. For images, we're just specifying namespaces just like we do with a plan. So basically, this controller is going to look at all of the image streams in that namespace and copy over any internal images there. Basically the same thing we do through Valero in the stage step of the workflow. Yeah, so we specified the source and destination, and we've got the same validation here where we check to make sure that the clusters are valid, the namespace exists on the side. So this is our source cluster. I have two different image streams there. And this is destination, there's nothing there right now. Create this CR, and basically we actually have two CRs. This is the MIG image migration, and we're just going to watch the run here, which basically specifies a set of namespaces and a source and destination. And what this does is first we create the namespaces if they don't exist already on the destination side, and then the create image stream migration step, we have a kind of secondary CR where basically for every image stream in each namespace, we create a CR, and then it has its own controller, which will actually do the copy work. So we have two of these running because there's two image streams, and that copy work has actually been refactored to use the same underlying code as the Valero plugin. So when you actually run a copy, where you're actually doing this, making use of the same logic that looks at each image stream, is it internal, copy the tags, the retrying logic as well, where if we hit an error, because we've had some problems where there are transient errors in the copy, we'll retry a certain number of times. That logic is built into the library that we're sharing from the. Okay, so now we're done with that. Let's check to see that the CR is done here. Oh, actually, I think I'm I was just showing the new field that we've added to the cluster, mid cluster. It's the exposed registry path, and this is something that the user in the UI there'll be a field that we're adding, specify that, and that's basically the exposed route created before. So we look at the MIG image stream migration. This is that second CR. There's two of them, one for each image stream. And we see here that it succeeded. So if there had been an image copy failure, you would have seen that here in the condition on this. And at the higher level CR, there'll be one error shown for each failure. So now if we look at the destination here, we pause this. Now we see that both image streams are here, and one of these had tags, so both images got copied. Actually, it's the same image here, but they had been different shots. They would have been two different copies. the underlying library prevents us from actually copying the bits twice. So there's one more here on the source side. That's because this was a alias tag where instead of, so basically anytime that first image tag gets updated, this keeps pointing to it. So that's not handled in our image copy, even in the Valero side. That's handled by our image stream tag plugin. So that would be unchanged here. I guess it's kind of analogous to the file system versus snapshot. There's certain types of image stream tags that we're not copying here because we're already copying them in Valero, and we're not physically copying an image here. We're just restoring metadata. The same is true for the external images, where the image stream is just a reference to an image that lives in some registry outside the cluster. That's just a Kubernetes resource restore, so we still use Valero for that. So that's it for this. The next thing we're doing this sprint is similar to the PV copy. We're going to be integrating this into the existing controller for MIG migrations. So there'll be a new step in MIG migration where if we're doing the direct image copy, we create the CR that we saw here, and then this MIG image migration controller will take over, and then the MIG migration will report. We'll basically pause on that step until completed, and then we, depending on whether it's failed or succeeded, kind of handle that accordingly. Any questions on that? Okay, well, that's it for me then.
Dylan, do you mind? Well, actually, for now, why don't you share your screen? You can go through your design document for progress reporting.
All right. I shared my screen. Anyways, can you guys see the document?
Yep, looks good.
All right. Yeah. So last two sprints, we have been focusing on this new feature that improves progress reporting in MIG controller. We have progress reporting shown in the MIG migration CR for Valero backup, Valero pod volume backups, and pod volume restore CRs. But Valero until Valero 1.4, Valero did not support progress reporting for Valero restore objects. This sprint, we worked on proposing an approach to have similar progress reporting for restore CRs, and we had a chat with upstream community, and we are hoping to get this in the next release of Valero, and then so basically all the work to show that progress as seen in the restore CR is done in the MIG controller. It's just that we don't have that info right now. So we propose this with the new improvements in the restore CR, then we will have progress information in the CR as shown here. That's the number of total items and the number of items restored so far. Until now, we only had this phase which says the restore is in progress, but with the new improvement, we'll have details like these. Yeah, that was all that.
Thank you, Pranav. Any questions on that before we move on to Alay? Cool. So Alay has been working on a number of improvements to general debuggability and trying to identify just sort of pain points and problem areas. One of the really cool things that he did last sprint, it's been kind of an ongoing investigation, is we sort of audited the overall controller to try and identify places that potentially could stall or fail. And there's an exhaustive design document that he's put together. So in case anybody, we can't go through it because it's pretty in depth, but in case anybody's interested in that, I highly recommend it. Anyway, I'll pass it over to Alay.
Sure. So we did three buckets of work this sprint. The first was related to make registry. Shubham is going to give a demo regarding that. Shubham, you can share your screen and start it off.
Yeah. Let me know if the screen is visible.
Yes, I can see your screen.
So this has a given voiceover. Let me know if the audio is not audible. I can give myself the audio right now.
Shubham, I don't think the audio will play unless you do that upload thing that Mike did. So you probably just want to talk over it.
Okay, sure. Thank you. So this demo is regarding make registry health check, which is a part of MTC release 1.4 fail fast feature. So little background being, we had analyzed around 15 customer cases, and it was observed that 15% of them had image or image stream related issues, and we had to bring around more reliability around make registry. That's why we implemented these three things. One was addition of liveliness and readiness probes to the registry deployment. Second was addition of custom registry health watch. And lastly, ensure registry health check stage in McPlan controller. So basically the combination of these three things enabled us to keep a watch on keep a continuous watch on make registry and cascade the status to McPlan. So like whenever we have a running migration and we have unhealthy containers, the unhealthy status of the containers is cascaded back to the McPlan, making it non-ready. So let's see a short demo regarding that. So here we can see the McPlan is in ready state, and we can even check on the details and see that the migration registries are in healthy state and the stage registry is healthy is true, set to true, and the pods are also in running state. If we run a stage operation and started off the migration. Now, in order to create a scenario, we'll use a egress network policy to shut off the network traffic, and this will make the container go in unready state. So we can see that the container is not available, and the status is like as soon as possible the container is unhealthy, it is cascaded back to the plan, and plan goes to not ready state, and it is shown in UI as well. We can even check up on the details of the McPlan. So the message even shows us which cluster has the unhealthy state as well as details about where the container pod exists. So helpful for debugging. Now we would like to revert to the happy state and see whether it resumes our migration or not by deleting the egress network policy. So once we delete and have the pod running in healthy state, it is cascaded to the McPlan and the migration is resumed from the state where it stopped. So yeah, I think that pretty much wraps up the demo and the state is restored over here. Just wanted to call out Derek. Thanks a lot for a very helpful and awesome review, and because it was a really massive PR, so it was really great, and obviously couldn't have done anything without Alay's guidance. So let me know if anyone has any questions.
Cool. Looks good, Shubham.
Yep. So one thing I wanted to call out was that this sprint we identified a scaling issue regarding this implementation and spent a lot of time to make sure that this is in accordance to our plan of keeping lots of plans open. So we reworked this entire thing with that in mind. With that, I wanted to move on to the logging enhancements. I'll share my screen. Can you guys see my terminal?
I can see
That's
terminal
good.
now.
Okay. So since logging is one thing which has perspective involved in it, we wanted to identify problems and solve and see what problems are we going to solve with addition of lockings. The two main problems that were identified and proposed solution is put up in this sprint is that once a controller is running, we would like to have a history of the timeline of the conditions that were processed by the controller on a CR. Since the conditions are transient, you could have a situation where the CR has moved into an unhealthy state, and from there on, it has, after few minutes or few hours or few days, it has moved to a healthy state. From a debugging perspective, it would be good to have that view of timeline in order to get at the root cause of the bug faster. So that was one problem that we solved by introducing logging of conditions at the end of each reconcile, thereby having a timestamp and the exact list of conditions that were processed by the controller on that CR. The other problem was identified as to the condition messages had a constant message. It did not have a context of what the controller was trying to do when it slapped that condition on the CR. So it would be good and it would be very helpful to have a contextual information that this condition was added to the CR because the controller couldn't find a kube resource, or the controller hit an error in finding the kube resource. Those were the two problems that were identified. I have an entire demo to simulate that and see how these conditions are added. But in order to save time, I have just gone to the last frame of my demo. You can see the conditions being logged here, and similar to the debugging experience, I will now backtrace this to the timeline that can be achieved with this logging improvement. So if you can see, I am grabbing on the storage controller. That's where these logging improvements were added. After starting the controller, the storage controller has moved to ready state. After that, within few seconds, I have added invalid credentials to the storage. That has driven the storage into not ready state because the test that runs on the storage failed. You could see explicitly that at this particular timestamp, the storage test started to fail, and you can see in the message that it is something related to the credentials. This points the user or the engineer who is debugging directly towards the secret that needs to be changed. You can see that after few seconds, about 23 seconds, I have changed the credentials back to the valid credentials, and the conditions have, or the CR has gone to ready state. After that, I have also tried to delete the CR that holds the credentials, and you can see that at this particular timestamp, the controller couldn't find, not found, the secret, and it also has the context that was added. So you can see that the OpenShift config Valero for this random text secret was not found by the controller. After a couple of those logs, you can see that the controller, I've created the secret back, and so the controller has gone into a ready state again. So this is a synopsis of how a developer or support staff can go back into time and construct a timeline of what happened with contextual information. Just want to pause there for a second. If anyone has questions regarding logging, feel free to do them now. Looks like not. Okay, so we have added these enhancements to the storage controller. In the next sprint, we'll take this as a blueprint, as a pattern, and we will follow other major controllers and add the same enhancements to those. Next thing I would like to do is to move to the audit that we did on the controller. The sprint review doc has a link to the doc that shows the failure or stalling scenarios that was identified. Just to be explicit, these weren't failure scenarios or stalling scenarios that were reported on the as bug reports or customer cases. This was just identified in the audit process as scenarios that could potentially fail or stall a migration. So there were two scenarios that were identified which we would work on in the last sprint. The first one was that there is a time between which the make migration controller creates the stage pod and ensures those are healthy, and before it starts Valero backup. What would happen if for some reason the stage pods went unhealthy between those times? Will it stall? Those were the kind of question that we were exploring. So the short answer to that question is, because we explicitly mentioned the node name on which the stage pods would be scheduled on, we do not depend on the kube scheduler. So the stage pods will not go into pending phase because of the kube scheduler. Once the controller has identified that they are running, and because all the controller does, all the stage pods do is sleep, it would be hard for them to go from running into not running state, except if something happened to the node. Now, there could be three things that could happen to a node. The node can go into totally disconnected state, the node can go into a no scheduled state, and the node can go into a node execute state. The totally disconnected state is kind of ambiguous because the kubelet does not have any information in case where the node is totally network partition and went into a disconnected state. The kubelet does not deterministically know what the state of the container is, so it will not change the state. Because we have ensured that our containers are running, it will continue to be in running state. The next thing that the kubelet can go into is no schedule mode. In case of no schedule mode, no new pods will be scheduled on this node. But because we don't use kube scheduler, our stage pods will be scheduled and run. The third thing is more extreme. It is no execute state, which means that all the running pods on this particular node will be terminated. So if the node on which our stage pod is running goes to no execute state, the pods will be terminated and killed. Because of the mechanism followed in Valero, which does not find the stage pods, it will not go through the Rsync copy. It will instead go to volume snapshot copy, which can be configured in a cluster, and this will not stall the migration to 1 hour of Rsync timeout, which was expected at the start of the sprint. So the conclusion of this scenario is that we would not stall the migration process. And because some of the scenarios are undeterministic, we cannot do anything about this. It would only have to be dealt with on a customer case-by-case basis. The second scenario is annotate resources. It was assumed that if you have service accounts that are in order of few thousands, tens of thousands, this phase can take a lot of time. However, after digging deeper, it was found out that the controller only annotates the resources that only annotates the service account that the running pods need in order for the migration to happen. Now, it was feared that RBAC resources can linger over time, but the running pods would not be in the scale at which this lingering of resources were expected. So there could be only few running pods, not in the order of few tens of thousands. Because of this, it was reasoned that addition of handling this case would introduce new complexities and we are better off not to pursue this edge case. So both of these prioritized failure scenarios were reasoned as something that we would not handle as of now because of the reasons mentioned in this talk. So I'll take a pause right now and take questions if there are any. Yeah, looks like none. So yeah, the end result of this effort is that we have a doc. Folks who are interested can go look into this doc and have a better understanding of what were the reasons we have discovered. And if you guys have any questions, feel free to reach out to me. That's it.
Thanks, Ale. Next up, we have Merrick, who will be showing the ability to trigger a rollback of a migration at will or on a failure. So this is useful because previously we did have a rollback mechanism, but it would only trigger automatically at the end of at the conclusion of a failure. So this allows you to choose whether or not you want to execute the migration. Merrick, I'll turn it over to you.
Yes, thank you. Can you hear me and see my screen? Can you see my screen?
Yep, looks good.
Great, thank you. So what I'm going to do is to demonstrate migration rollback on demand. Change from the previous situation or previous implementation is that the rollback is not automatic on failure or something like that. The migration itself, it's either successfully or fails with error or something, but anyway, it completes. And then there is a new migration, which is called rollback, which performs actually the rollback. About my demonstration, I have prepared a MIG plan and also two CR definitions with YAML. And basically, the first one is for migration run, nothing special about it, just pointing to the plan. And the other one is called rollback, and that's the interesting thing, which is rollback true flag, which is part of the spec file or the spec section. And this basically says that the MIG migration will follow the rollback itinerary, which performs the rollback action. As the first step, I'm going to do the migration. There is also I'm watching the resources in the Rocket Chat namespace, which is the application used for this demonstration. The migration itself, the first part, it's really nothing special, so let me quickly skip it. In the log, everything is running, and we should get to the point when the initial migration is completed and the UI is completed too. And now what I'm going to do, we can also check that the migration has been successfully migrated. Namespace Rocket Chat on the destination cluster is populated with resources. And we can see the migration is completed. And right now I'm going to create a new migration, which will have set the rollback to true, and which will proceed to the actual rollback. When a rollback starts, we can see there are actually two migrations. Also, the controller log files print that there is a mig rollback and following steps from its itinerary. I will again, for the time reasons, skip this part a little bit. In the UI, there is visible that the one migration is complete, other one is in progress. Yeah, now the mig rollback has completed. We see that itinerary is done. Also in the destination cluster, most actually, like everything with this one orphaned pod exception has disappeared. So the rollback is completed, and currently there are two migration objects which both are completed. In the UI, so far there is no update. So the first one actually should be the rollback. There is open issue on for UI, so that's one of steps which needs to be done in next sprint, which is update the UI. The other part which needs to be done in next sprints is, let's say, enhancements or stability improvements and additional checks for the rollback action, which should ensure it's really reliable and works well on as many applications as possible. The regulatory already created some issues. We are working on that, so that should continue. I'm happy to answer any questions, and otherwise that's it from me.
Great. Thank you, Merrick. That's a good segue into the last section, which is Vince showing off the mockups for the 1.4.0 UI features that are to be implemented during sprint 192, which is the current sprint that's starting today. The last sprint was largely like back-end work that was hooking up APIs and making those available. And during that sprint, our goal was to make sure that we had the mockups ready for sprint 192, which is the sprint, which is when we'll be actually implementing those the UI features, so that we've got an end-to-end feature to meet our feature complete date at the end of the sprint. So Vince, I'll pass it over to you.
Hey, Eric, it looked like in the chat, Vince said he had to drop, so said he would schedule a separate meeting.
Missed that. Thank you, Todd. Okay, well, it sounds like that probably concludes the review then. Anyway, that is the plan. So we have a lot of the backend features in place for 1.4.0, and we put together the mocks for the 1.4 UI pieces. And so this sprint, we'll be implementing those and showing off those features at the end of at the next review. So that's the end of the agenda. Is there any questions outstanding? Anything at all before we conclude the meeting? Great. Thank you, everybody.
Thank you.
Thank you.